Okay, so we will go through each option one by one. Before that, I would like to show you a real experiment.
Flooding is the leading weather-related killer, and more than half of those deaths happen in vehicles. I'm going to take this car and put it in that water and get out to show you how to get out alive in case this happens to you.
Okay, so I'm not going to show you the full video, but then if you try to go and play the video, or if you try to look at what I'm trying to show you right now, you can see that their car actually are closed with windows. Okay, and unfortunately you can still see the car is sinking because the water are leaking into the car and dragging the car down, and therefore there was an option saying that you can shut the window. Unfortunately, it won't help you.
It's not flooding in to where you can then use your seatbelt, unclick it or cut it, and break the window, and out you go.
Well, the thing is, who would have these kind of window breaker at the car? Do you? Do you? Okay, assuming you have got that and you can get out of the window immediately, then yes, you are safe. However, most of the time, you have a situation like this. The water are flooding into the car and it actually creates a strong current against you. Unless you are professionally trained as this diver, it's not easy for you to get out of the car against the current. In other words, B is definitely not going to help. You probably should crawl out directly if possible. If you're not reaching the water level yet, then yeah, crawling out from the window would be good. But then if the water are already flooding into your car, like me here, then probably it's not going to work. And so the question leaving us with is whether or not we should push the door as hard as you can directly, or we should wait. In order to analyze this, we need some physics. Okay, let's look at plan C first. In order to understand this and knowing how much force you need to open the door, you need to know the dimension of the car door. Because when you open the door, you are actually against the pressure from outside, which is given by the sea, by the water. And so thinking that inside the car is still mostly air, because the water are going in but not yet fully covering at the beginning. So let's assume inside the pressure is the air pressure, atmospheric pressure. So normally it's around 101 kPa. And outside you will have the water pressure due to, of course, the water itself, depending on how deep you are. So let's say you are only in, say, I don't know, 2 meter, right? Would that be good enough? So around this level, 2 meter depth. And so at that point, you want to push the door to open. And so how much force do you actually need to do? Maybe you can pause the video if you are interested to calculate this.
A few moments later.
Okay, let me show you how I will do it. In order to calculate the force opening the door at this moment, we have to use some simple physics equations that will include P equals to F over A. The P is the pressure difference between the pressure inside the car and outside of the car. And so in this case, as we said, inside the car, assuming there's only air, then that will be the atmospheric pressure. And outside, it will be the total pressure at 2 meter depth of the sea. For that, we can calculate it by rho GH equal to the pressure plus the atmospheric pressure, all right, for the total pressure outside of the car. And therefore, the difference between the pressure outside and inside, you will have the atmospheric pressure cancel out and leaving you with rho GH simply. And then the force F is the force that you need to push the door, and A will be the one that is of the size of the door. And so in this case, we can then substitute all the numbers that we know, because rho is the density of the seawater, which is roughly 1050. G, we can take it as 9.81. H, as we said, is 2 meter. Force is the unknown. A, I find there's a diagram here which these are in cm, so the door is roughly 1.2 times 1.3. Of course, this is estimation. Eventually, you'll be able to find the force, which you should find the force is roughly 32137.56 Newton. So roughly 32,000. Let's just write K Newton. Right? Okay. So what's the idea of 3.2 K Newton then? If you look into the world record for weightlifting, well, I think most of the athletes can only do roughly 200 kg, roughly. And that actually means when they lift up that mass, it's going to be 200 kg times 10, which is about 2,000 Newton. So how would it be possible? Because the force that we calculated is more than 3,000 Newton, and even the best people in the world can only lift up in such a nice condition with around 2,000 Newton. So it's actually impossible for a normal human being to open the door in this situation. And so that is to say, C is definitely not something you should do when this accident happened. Looking back, B is not okay, A is conditional, then D probably is the last resort you should do if you have such an unfortunate incident. And that is to wait, not for dying, but wait until the water get into your car and fill up your car. Of course, you have to maintain your breath so that you can maintain your oxygen supply in your body. But the most important thing is once the water fill up your car inside, then the pressure will be the same as the pressure outside. Since there's no pressure difference between outside and inside, you can open and push your car door as usual, just like how you do it on the ground. So I'll say again, step number 1 is to don't panic, step number 2 is to just wait, and step number 3 is to just push the door, open it as usual, and escape and swim. Were you surprised that you have to wait for the water to fill up your car before you can get yourself escape from this accident? If you like this kind of story, go and check out this book called Physics for Rockstar: Making the Laws of Universe Work for You, written by Christine McKinney. I find this question on this book and it is fascinating to know about other stories too. I hope you enjoy learning physics with me. If you do so, please hit the like button and subscribe to my channel. I'll see you again in the next physics video. Bye!